Okay, marhaba. So this is another session on summations. Okay, what we will do is we want to find what is the summation of the terms in a geometric sequence. Do you remember what are geometric sequences? So geometric sequences. Remember, we start with two numbers, real numbers. We call them A and R, and this is the initial term and this is the common ratio. So the first term of the sequence is A. The second term is we multiply A by R. The third is AR squared. We keep multiplying by R, right? These are the geometric progressions. AR cubed and so on. And suppose we stop at n. So AR to the power n. And again, we are doing summation, so we want to sum these terms. So we want to find A plus AR plus AR squared plus AR cubed and so on, and we stop our summation at AR to the n. We learned the sigma notation. What is this? How can we express this using the sigma notation? This is equal to the summation of the nth term or the kth term. What is the kth term? A r to the power k. But k starts from 0 here, right? Because a r to the power 0 is a, and then a r to the power 1, and it stops at n. So notice that these are n plus 1 terms. All of these are n together with the first one, n plus 1 terms. So we want to find in general what is this number. Okay, so what is the summation of the terms in a geometric sequence? So there are two cases here. Case 1, if R is 1, if the common ratio is the number 1, then what we will get, so look, this is A plus R squared is 1 squared A, so we are summing. So in this case, the summation of AR to the K, where k ranges from 0 to n. Now since r is 1, 1 to the k is 1, so this is the summation of a from k equals to 0 up to n. And so what is this? This is the summation of a constant sequence, a. So we want to sum a plus a plus a, but how many times? Okay, notice from 0 to n we have n plus 1 times. So this is n plus 1 times a. So this is the summation of the geometric sequence, or the constant sequence if you want, from 0 to n. Now case 2, which is the more interesting, if the common ratio r is not equal to 1. Okay. Now again we use the same trick that we say let S be the summation of AR to the power k, where k ranges from 0 to n. And recall that this is, when k is 0, this is A plus AR, when k is 1, plus AR squared, and we stop AR to the n. We want to find this summation. We want a formula for S. Now what is the trick? Is that you take S, this summation, you multiply it by R, the common ratio, and you subtract S. Okay, maybe the same S. Okay, see, let's see what is this number. So this is R, and what is S? S is all of this, right? It's A plus A to the R, 8R plus AR squared up to AR to the power n, and then minus again S, where S is again the same thing, AR plus AR squared plus up to AR to the power n. Let's simplify. What do we get here? Now look, A times R is AR, R times AR, you get plus AR squared plus AR cubed, and then say AR to the power n plus the last one, AR to the power n plus 1, right? If you multiply R by the last term here, you get AR to the power n plus 1. Now minus a, so minus a minus ar minus ar squared minus up to minus ar to the n, right? Now again, addition is commutative and associative, so check that here we have ar minus ar squared minus ar squared, and so on up to ar to the n minus ar to the n. So what we are left with, two terms, this term and this term. So this means that rs minus s is equal to a r to the power n plus 1 minus a. Okay, this is n. So this is what we have. This means, so let's take s as a common factor. So s multiplied by r minus 1 is equal, so if you want, so, or therefore, let's take s from here as a common factor. So s times r minus 1 is equal to a times r n plus 1 minus 1. Is equal to this one, and we take a as a common factor. Now we can divide by r minus 1 because r is not 1, so this number is not 0. So s, which is the summation of ar to the power k, where k ranges from 0 up to n plus 1, is equal to a multiplied by r n plus 1 minus 1 all divided by r minus 1. See, we found the formula for this summation. Let me put it in a red rectangle. You see, this is the summation. Sorry, up to n. So, okay, do you want to have an example now? So let's see. Here's an example. Let's take the summation. Let's say a is 2 and r is 3 and k ranges from 0 to 2. So this is, so what is this? This is 2, right, plus 2 times 3 to the power 1 plus 2 times 3 to the power 2. K ranges from 0 up to 2. Now this is 2 plus 2 times 3 is 6 plus 3 squared is 9 times 2 is 18, and this is equal to 26. Let's check our formula. So what does the formula say? So the formula says, here is the formula. Okay, let me do it here on this side. So what is a? A is 2 multiplied by what? Okay, 2. What is r? R is the common ratio. It's 3 here. So it's 3 multiplied by raised to the power n plus 1. N is 2 plus 1 is 3 minus 1 divided by r minus 1. Again, what is r? It's the common ratio. 3 minus 1 is 2. So 2 over 2 is 1. And this is 3 cubed is 27 minus 1 is 26. See? It worked for this example. So, moral of the story, the summation of ar to the power k, where k ranges from 0 up to n, is equal to n plus 1 times a if r is 1, and otherwise it's equal to a times ar to the power n plus 1 minus 1 divided by r minus 1 if r is not equal to 1. And see, we need that r is not equal to 1 because we are dividing by r minus 1. Okay, so this is the formula for the summation of the first n plus 1 terms of a geometric sequence. Okay, now let's have a different example with a double summation. Okay, so let's have another example. Find this is an easy example. So find the summation where the index I ranges from 1 to 4 of the summation where j ranges from 1 to 3 and where the terms is I times j. Okay, so let's compute the inner summation. So the outer summation I will write it as it is, but what's the inner summation? So j ranges from 1 to 3. So when j is 1, 1 times I is I, and then I sum. I increment j by 1, it becomes 2. 2 times I is 2i plus, and this is the last value of j when it's 3, and 3 times I is 3i. Right? And now this is equal to, what's I plus 2i plus 3i is 6i. So this is the summation of I ranges from 1 to 4 of 6i. But we know that from the very first properties of the sigma notation, this is equal to 6 times I, where I ranges from 1 to 4. And note, so this is 6, but what is the summation 1 plus 2 plus 3 plus 4? This is, we know the formula of this. This is n, so this will be n times n plus 1 over 2. So this is 4 times 5 over 2. This is the sum of the first 4 positive integers. And 4 over 2 is 2, 2 times 5 is 10, 10 times 6 is 60. Okay. So this is the value of this double summation. If you want, you can forget about these brackets. So this is the summation of this of I times j. Okay, let's have another example. Given, so here is another formula for the summations. Given that the summation of k squared, we didn't prove this, I'll let you think about it, where k ranges from 1 to n. Okay, so what is this? When k is 1, this is 1, plus when k is 2, 2 squared, plus 3 squared, and you stop when k is n. So if you sum the first n squares, the claim is that you get n times n plus 1 times 2n plus 1 over 6. Okay, I'll let you think about this. You have to prove it in the assignment. Okay, so what is n? N is the upper limit of the summation. So suppose we are given this, and then the question is, find the summation of k squared, where k starts from 50 and stops at 100. So what is this? This is 50 squared plus 51 squared plus 52 squared, and you stop at 100 squared. But look, the formula we have doesn't start from any number, it always starts from 1. So I want to use this formula to compute this sum. And the idea here, okay, let's see what is the summation from 1 to 100. So notice that the summation of k squared, where k ranges from 1 to 100, is 1 squared plus 2 squared plus, let's see, plus 49 squared plus 50 squared plus up to 100 squared. So notice what we want is this one. We want the sum of these terms from 50 to 100. So you see that we have to remove this part from the summation of k squared, where k ranges from 1 to 100, to get the red part, the wanted part. So this means that the summation of k squared, where k starts from 50 and ends up at 100, is the summation of k squared, where k starts from 1 to 100. So this is the summation of all the blue terms, minus, I want to remove the green part. So which is what? The summation of k squared, where k starts from 1 and stops at 49, right? But we know what is the summation of this one. It is, we use the formula here when n is 100. So when n is 100, we get 100 times 101 times 201 divided by 6. See, we use this formula when n is 100. So it's 100 times 101 times 201 divided by 6, minus, we use the formula when n is 49. So we get 49 times 50 times 99 over 6. And you see that this number will be a big number, but not very big, 297,925. So this is how we, what is this number? This is the sum of these numbers, 50 squared plus 51 up to 100 squared. Okay, so this number is this sum using this formula. Okay, let's have one more question. Okay, find the sum of the following numbers: minus 100 plus minus 97 plus minus 94, okay, plus minus 91, plus, we keep doing this up to 101. So what is this summation? How can we think about this question? So the trick here is the sigma notation. The first thing you have to do is write this in terms of a sigma notation. And in order to write this as a sigma, in terms of sigma notation, we need to find what is the nth term. So if we call this as a0, so let me write it in blue. So if minus 100 is a0 plus a1 plus a2 plus a3 plus, and say we stop at an, we still don't know what is n, the last term. Can you see what is this? If we forget about the plus, this is a sequence. And what is this sequence? This sequence is an arithmetic sequence. Arithmetic sequence where the first term a0 is minus 100, and the common difference d is c is plus 3. Look, how do we move from this term to this term? By adding plus 3. And from here to here, we add also plus 3. We keep adding plus 3 to get the new term. And we know what is the formula here, that ak, so the kth term is a0, which is minus 100, plus kd, so 3d. You want, sorry, 3k, where d is 3. So when k is 0, look, we get minus 100. When k is 2, sorry, when k is 1, then minus 100 plus 3 minus 27, and when k is 2, we get a2, which is minus 94, minus 100 plus 6, and so on. So what we are doing here, we are summing all the ak's where k starts from 0 and ending at n. Okay, the summation of what is ak, it is minus 100 plus 3k, where k starts from 0 and stopping at n. So we still need to find what is this n. So an is when the nth term is 101, right? The last term has value 101. So we want to find when an is 101. But what is an? An is negative 100 plus 3n. So here we have negative 100 plus 3n is equal to 101. and 3n is equal to 201, and this means that n is equal to 67. Okay, so this means that this n should be 67. So let me rewrite it again. So again, we want to find the summation where k starts from 0, stops at 67, of negative 100 plus 3k, right? This is what we are aiming to compute. And now we will use the properties of the sigma notation. So this is equal, remember, the summation of two sequences is the summation of each sequence. So this is the summation of negative 100, right, where k ranges from 0 up to 67, plus the summation of 3k, where k starts from 0 and stops at 67. And now we've seen that this is a constant number. We can take it outside. This was the first property of one of the first properties of the summation from k equals to 0. Or sorry, let me see. When we sum the same number with itself, how many times we are summing? K ranges from 0, 1, 2 up to 67. This means we have 68 times we are summing negative 100, right? When this is the summation of c, where c is a constant term. Okay, so here the constant term is negative 100. So I'm summing negative 100 plus negative 100 plus negative 100 68 times from 0 to 67. Plus, now this is a constant, I can take it outside, and this is the summation of k, where k ranges from 0 to 67. This means, what is this summation? It's 0 plus 1 plus 2 plus 3 plus 4 up to 67. Because the first term is 0, it doesn't change the summation. So I can just say it starts from 1. And okay, so now what do we have? This is negative 6,800 plus 3. And look, what is this? The summation from 1 to 67. This is the summation of the first 67 positive integers. We know what a formula of this. This is 67 times n plus 1, which is 68 over 2. Right? And you can check it that this number is 6,834, and you will find that the number is 34. So in other words, if you sum the green numbers, you will get the number 34. Okay. Thank you.